This is Nick, and I'm with Atlantic Laser Scanning Services. Today's tutorial is going to be using FARO scan data in FARO Scene software collected using a FARO S150 Focus scanner. It's a little different in that we actually were using sphere targets for the registration. As you might know, most of the time the FARO Scene software is able to use the geometry around it, whether it's walls, furniture, equipment, uh, to auto-register the project together. But when you are out in an open area, such as this project, you have no geometry really around you. Everything is natural. It might be grass, it might be trees moving, blowing. Can't really use that effectively as registration points. So using the sphere targets, we're going to register the project together. And there were also uh, hyperscans that were conducted during this scan project. And we're going to show what the hyperscans are, how they're incorporated into the project. So let's take a look. So as we go into our data here, we're going to take a quick look at what we have, because what we're doing is going to be a little bit unusual. We have 6 scans, but as you can see, we've got already 3 clusters that have been created, not manually, but automatically. Why is that? Because we have 3 full scans and 3 hyperscans. We can take a look at what a full scan and a hyperscan looks like, what the difference is. We open up the full scan of this island oyster bed, and as you might expect, a non-colorized quick view looks like this. Now, the Hyperscan, if you haven't seen any of our previous videos, is a method of scanning where you keep the scanner in the exact location. Once you finish the scan, you go in, and whether it's an S series, say a S350, an S150, like this data was done with, or a Premier scanner from FARO, you have the option to choose a section of what you scanned and uh, throw more points at a small section. Maybe it's a meter square or 2 meters square. If, for instance, you wanted to scan the side of a building and things are a little further away than normal, you want to get real nice, accurate data in one particular spot, you can use a hyperscan. In this case, as we can take a look here, the study was uh, looking at a particular part of the oyster bed. We loaded this scan. We're going to look at that scan in 3D. Here is our hyperscan. Now you can see exactly what happened. The scanner just took a small section of this full area, and the hyperscan just took a very small section, threw more points at it. This is then added to scan number 9 in this section, say here, so that when they go in and they do some measuring, they have more points on there, and the odds of our accuracy going up is greater. So that is the data that we're looking at. Now, for us to register this project together, we're going to start with pre-processing because we have sphere targets as our means of registration. So first we have to tell the software that we use the sphere targets. By pre-processing, we identify the targets in each scan. So we go to pre-processing scans, we choose the top or the full cluster, configure pre-processing. Now, before we go any further, we're going to make some changes. We're going to skip the fully processed scans. We're going to take that option off. We're going to take off the create scan point clouds, because we'll go into this a little bit later, but this is going to take more time. And we really do recommend getting your registration dialed in before you create the point clouds, the project point clouds. So it just takes longer, and every time, say you've got 50 scans and one of them didn't come in correctly and you have to manually move it around, every time that you make a change, you have to update that point cloud. First, get your registration right. Second, create the project point cloud. Lastly, we've got non-colorization. We've talked about this in previous videos, but my personal stance is, if you have ever scanned outside Eventually, you'll run across a scan that maybe the sunlight sort of overexposed the camera photograph. And what you end up with, if you apply those photographs to the point cloud, it looks like it's just a big white image and you can't see your data. The truth is, if you didn't colorize it or if you remove the camera photograph from the data is all there. Conversely, if you are in a small or an interior part of a building and the lighting's not great, if you add color, you may have things that are maybe underneath a table or back in a corner that didn't get light on it and it looks like just a black hole. All the data from the laser scanner is there. If you remove the photographs, the colorization of that point cloud, then you'll see all the data just like you did when we were looking at our quick view earlier. And again, it does save us time. Lastly, most importantly, in this section, we are going to tell the software to look for the sphere targets. In here, the radii that's listed, that's all default. If we were, say, using, a larger sphere or an odd size sphere, we could add the radii here for the software to look for it, but we're good. We'll just start the pre-processing option. It's a small little project. This doesn't take more than a couple minutes to be done. All right, we've got our processing results. To see what we've done, we can go back in and look at, say, one of the full scans. This quick view or 2D view of our project, you can see again the oyster bed island and our sphere targets. If they were close enough, they have now been identified by the software with this green sort of 3D color here. Now you see a couple that didn't come in, and that's because they were too far away. We do not recommend a small sphere like these 140 millimeter spheres being more than, say, 30 to 40 feet from the scanner. They just don't get picked up. They're just too far away from the scanner for the software to recognize it. So what we've done now is identify the targets that we're going to be using for registration. So now we go into registration. The top of the middle of the screen, we choose registration, perform automatic registration. Now we're stopping again. We do not do anything until we change the method of registration. FARO Scene's default method of registration is top view and cloud to cloud. This is because most projects don't need sphere targets anymore. It's using the automatic features of the scene software. If you've got a building that you're inside of or outside of, equipment that's around you, furniture that's around you, if it's all stationary between scans, the software looks at the geometry of these pieces and uses that geometry to put the scans together in registration. Because we're using sphere targets, there's no geometry around us. We need to tell the software to use target-based registration. We just simply go ahead and hit register and it's done. We load the project up and judging by this correspondence view, we've got a nice hard edge on our oyster bed. We can look at it from the side. Yes, we've got the same elevation on the different scan locations. That looks good. We'll say yes, finish. We're going to return to the dashboard, jump into Explore. Here is our register project. We've got green lights on our scan manager over here, which tells us that everything below it has come together correctly. Now we can also look at this in a correspondence view, which will be much more telling of what we've just done. We're loading the scans up. And you can see the overlap then with the scans. This is what we're looking for. Our number 9 scan location is red, green for 11, blue for 13. And you can see this mixture of colors as we go through and we look. That's what we want. Um, if we've got correct scanning techniques, whether we're scanning a road, the side of a building, a piece of equipment, we will have good overlap, and that keeps our accuracy good throughout the project. One more thing, if we want to see where each scan is, obviously we've got scan number 9 there, but more importantly, look here, we've got one of our Hyperscans. It's inside of scan number 9. You can easily see where we were highlighting for more detailed data right there inside of scan number 9. Now, essentially, this project is completely registered. At this point, if you would like to colorize it, you simply go to the main scans folder over here on the left, right click on it, go to operations, color pictures, and apply pictures. If you want to create a clip box, which would allow you to temporarily get rid of all this other data and just center in on the 3D of this down here, easy to do. You go to the project point cloud option here and create one first. This allows your system to look at all of the point clouds in 3D without actually loading these scans on the tree over here. It's just easier on your computer, especially if you've got 50, 60, 100, 200 scans. Lastly, once that's created, you can go and create a clip box and then temporarily delete any of the data that you want. I hope this helps with your understanding of registration with sphere targets and also what hyperscans are and how they're used. Thanks and good luck on your next project.